Hi again, Captain Peter Cutsie with another of my online briefings. This particular one applies to any aircraft, not just the 737 NG or the MAX. However, the reason I am putting it out for your viewing is as a review of the importance to understand angle of attack. We've mentioned the angle of attack previously in my steep turn video and also in the approach to stalls. But being that many of you will be taking new training for the 737 MAX, part of that training is for the MCAS activation given during an impending stall and recovery demonstration, and a demonstration of MCAS activation stabilizer trim responses, and stabilizer trim in the nose down direction when above threshold angle of attack for MCAS activation during a stall, and also stabilizer trim in the nose up direction when below threshold angle of attack for MCAS activation during recovery. The pilots will also undergo runaway stabilizer training, requiring them to use the manual stabilizer trim techniques during approach, go around, and level off. I'm reading this as an item that has been put out by the FAA recently. So in view of this, I thought it wise to review what the angle of attack is. Many of the 737 NGs, depending on what option your company ordered when buying them, don't have an angle of attack indicator. You have to actually figure it out, and I'll show you how to do that. The objective of this briefing is to have a better understanding of three critical angles. I've talked about this before in my approach to stalls. Pitch angle, flight path angle, and angle of attack, which is not fully understood in the aviation world. Let's go and have a look at the three critical angles again. The first angle I spoke about is the pitch angle, and that is the angle that the longitudinal axis of the aircraft makes with the horizon, as I'm showing you here. The flight path angle is the angle your aircraft is actually flying through the air with respect to the horizon. On takeoff at 79,015 kilos, your pitch angle on a hot day will be 15 degrees, which is normal. You pitch, you rotate up to 15 degrees, towards 15 degrees. For all intents purposes, we'll say 15 degrees. But the aircraft flight path through the air, because of perhaps high elevation, hot temperatures, and heavy weights, will be much less than 15 degrees. Maybe it would only be 8 degrees, as referred to here. And what I'm pointing out here is the actual flight path is considerably less than the pitch angle. On a very cold day, very light, at sea level, your flight path angle will be perhaps just slightly less than your pitch angle of 15 degrees. All right. The last angle is the angle of attack. It happens to be the difference between the pitch angle and the flight path angle. So this picture shows you that, but I want to make it a little easier for you. So let's carry on with this briefing. First of all, on the 737, whether it be the NG or the MAX, on the mode control panel, you have a button called Flight Path Vector. If you push that, you will bring in the flight path vector. So the flight director is displayed when the related flight director switch is on. Pitch and roll commands are displayed independently. However, the flight path vector symbol represents airplane flight path angle. So for all intents and purposes, it is your flight path angle. This is from the FCTM, incidentally. Now, displays the flight path angle vertically and drift laterally. So if you have no drift, the flight path vector symbol will be at the center of the symbology. If the wind is from the left, the actual symbology will be to the right. So let's go and maybe have back to that and have a look at that. If you have HUD, this is the flight path vector. You would actually place the Q inside, and for those of you who have HUD, you'll understand what I mean. That's what it looks like. And this is an angle of attack indicator. So this, in this particular picture, the angle of attack is 5. So you actually have that symbology if you have HUD. Now, many aircraft companies don't have HUD on board. The actual symbol you will see on the primary flight display when pushing the FPV on the mode control panel is here. This is what it looks like. It's white. This is the aircraft symbology for the aircraft's position, and this is the flight path angle. In this particular circumstance, the airplane is pitched up at 3 degrees above the horizon in a 20-degree bank turn to the right, and is in level flight because the flight path angle is 0 on the horizon. We'll talk more about that when we have a look at it. So to make things simple, I've used color, and I've used a little coloring pen. It's not perfect, but you'll get the picture, pardon the pun. So before we go into the picture, let me show you an extract directly from the QRH performance chapter. So what's coming out of my mouth is directly from the Boeing manuals. So we're looking at, for all of these examples, we'll be at a weight of 60 tons, which is close to the max landing weight, we'll say, a little under the max landing weight. So this particular performance chart is at 5,000 feet and at the flaps up speed, which is VREF 40 plus 70. And the pitch reference for this weight is 5 degrees of pitch. So let's go and have a look at something that I designed here to make it easy for you. Here's the aircraft symbol, not exactly the way it is in the airplane, but close. And each of the white scale, pitch scales, represents 2.5 degrees of pitch above the horizon, 5 degrees above, 7.5, etc. So in this particular case, the aircraft is pitched at 5 degrees above the horizon, and we'll put a green code for that. The flight path angle is 0 because we're on the horizon. Remember, the flight path angle is the difference between the aircraft's pitch angle and its flight path. Well, in level flight, your flight path is on the horizon, so your flight path angle is 0. Therefore, the angle of attack is 5. So that's how you can figure it out unless you have an angle of attack indicator. And if you notice, folks, the actual physical distance between the center of the aircraft symbol and the flight path vector, which is your flight path, representing your flight path angle, the distance between is not that great. It happens to be 5 degrees. So it's not that great. I want you to remember that in all these examples. What I'm getting at is if the difference between your pitch and your flight path angle is greater than 6 or greater than 7 or 8 or 9, you should start to be concerned. If you remember in my approach to stall briefing, on the level off stall, I had the autopilot was engaged, and the instructor brought the thrust levers to idle, so the speed would drop down and to the amber band, the minimum maneuvering area, and right through to the shaker. At that point, I had mentioned to the pilot monitoring to watch the flight path vector. And the actual flight path angle was close to 12 degrees at 60 tons at 5 degrees of flap. So if your pitch angle, or I should say, if your flight path angle and the difference between your flight path angle and your pitch is a small amount, you know you're more than likely safe. But as that difference increases above 8 or 9 or 10, you should be very concerned that something's happening. All right, let's go back and have a look at the perf page, level flight flaps 5. And we're looking at, here's the chart from the manual, QRH, flaps 5, gear up, BRIEF 40 plus 30. You're 6 degrees of pitch. Okay, let's go and have a look at that. So I've kind of, again, changed the color of the flight path vector to make it a little easier to see, because white against white on a white line is a little difficult to see. So perhaps a tip for the instrument manufacturers for the next version of flight path vector to color code if the difference between the pitch and the flight path angle becomes excessive, and that could be in the neighborhood of something greater than 8 or 9. So here we are pitched up at 6 degrees, we're at flaps 5, we're in level flight. So the flight path angle is 0. And we know that the difference between the pitch and the flight path angle is the angle of attack. Therefore, in level flight, whatever your pitch is, that's your angle of attack. Wow. So you know that probably 94% of any flight you fly, if it's a long-range flight, and if it's a short-range flight, perhaps a smaller percentage, that you're actually in level flight. You may be pitched up slightly in level flight, but it doesn't matter. If you're in level flight, your flight path angle is 0. So your angle of attack is your pitch. Another circumstance, let's go to the performance page again on a 3-degree glide slope, where the gear's down and flaps 15. Here's the performance from the manual, flaps 15 at BRIEF 15 plus 10, and at 60 tons, your pitch is 2. So if you're on a 3-degree glide path, the glide path is -3. That's the angle that the glide slope makes with the horizon, -3. So the difference between -3 and a pitch of 2 degrees is 5. So generally, on final approach, depending on your flap, in this case it's flaps 30, on the 737NG or on the MAX should be very close. I don't have the figures on it yet, but very close. You're looking at an angle of attack of 5. And if you remember that little picture we saw on the HUD example, it was at 5. Okay, so important. Let's go back. Now let's have a look at another scenario as we progress through the ILS with landing flaps. At flaps 30 on a 3-degree glide slope, here's the performance. Flaps 30, BRIEF 30 plus 10, you're pitched up at +1 degree at 60 tons. Now let's have a look at the picture. There's your pitch up of 1 degree, and you're on a glide slope of 3 degrees, which is -3, so your flight path angle is -3. The difference between your flight path angle and your pitch is your angle of attack. So your angle of attack is 4. Okay. Now let's go through one final bit. Let's have a look at your go around. So go around, flaps 15, and the gear up is what we're going to be looking at in this picture. So the go around in this particular circumstance is 18 degrees. At 60 tons, that's what it's going to be. We saw that. 18 degrees. I forgot to mention it. That's at sea level. 18 degrees at 60 ton. 18 degrees. All right. Here we are pitched up at 18 degrees, and our flight path angle is probably less. Of course it's going to be less, as we mentioned before in the initial part of this briefing. So in this particular case, the flight path angle is at 14 degrees, so the difference is 18 minus 14 is 4, so your angle of attack is 4. So some of the observations that you probably made through all this is your angle of attack in most phases of flight. We didn't talk about the takeoff, but the takeoff is going to be very similar to the go-around. You're going to be pitched up between 15 to 18 degrees. Your flight path angle is going to be less than, as we mentioned when I pointed that out on the critical angles, going to be less than 15 degrees. So here again, the angle of attack is going to be somewhere around 4 degrees. So if you've noticed from this briefing that most of the time under normal conditions, you're looking at an angle of attack of around 4 degrees. Something easy. If it's 8 or 9 or greater, you're in trouble. You're doing something that's not right. Perhaps the autothrottle has become disengaged and 2 very tired pilots have missed it. And the trim wheel is going chunk, 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 and nobody is picking it up. Meanwhile, the pitch angle is increasing. The autopilot's doing its job. It's maintaining level flight. Meanwhile, the trim wheel is going nose up, chunk, chunk. And if you haven't watched my stabilizer, trim, and operative briefing, you'll understand what I'm talking about. It's so important that you know your airplane. Why is the autopilot trimming the nose up? It's because the airspeed is decreasing if your autothrottle has failed, and your pitch is increasing, and everybody's perhaps tired and not watching it. Make sure you turn up the brightness on your PFDs on a night flight, especially a long flight, and fly your airplane. Remember what I said in the last video? Autopilots do nothing for a pilot. Nothing, except to take away the manual handling. Make sure you fly your airplane, be professional, be passionate, and I'll see you in the next video. Thank you.